So once the design has been implemented and simulated in ModelSim, the next step is to load this design onto an FPGA. In order to do that, we need to create a top-level module that maps the inputs we used here, full adder, A, B, C in, sum, and C out, to the inputs and outputs of the GE1 SoC board. So what we need to do, we need to create that top-level module. So we'll go to File, New, SystemVerilog HDL file, and we're going to save it as ge1_soc.sv. Save. And then we're going to write the module for the GE1 SoC. Okay. So here's the GE1 SoC module, and we have the hex 0, 1, 2, 3 up to 5, which corresponds to the 7-segment display on the board, and we have the key, the red LEDR, and the switches. For the LEDR, the key and the switches, we have them as vectors, and also for each of the hexes. And then we are instantiating the full adder. And here is how we map what is A. The A was an input in the full adder module, and it corresponds to switch 2 on the board. Okay, so this is how you will write it. Dot A and then switch 2. And then B corresponds to switch 1, and CN corresponds to switch 0. And make sure you write switches as capital letter, SW, and the same for the hex zeros and for the LEDRs and the key. And the sum, we are mapping the sum to the LEDR 0 and the C out to the LEDR 1. Also, for the hex displays, we are initially turning them off. So we put 7, B, and all ones, and you notice here these are 7 ones because we have 7 segments. The 7-segment displays are active low, which means in order to turn one of the segments on, you need to change the corresponding segment from 1 to 0. So this will turn it on. So in short, 0 means on and 1 means off. Okay, so this is the module for the GE1 SoC. And we also need to create a test bench for this module. Okay, so here's my test bench for the GE1 SoC. Okay, so I have the hexes, the LEDR, the key, the switches, all as logic. And the DUT, the device under test. This is the GE1 SoC. And here we are creating a test bench, initial block, and using for loop. We're not using all the switches, we actually use 3. We're going to use 3 only. But wanted to show you when we create this for loop for a lot of combinations, 2 to the power 8. So we said the switch 9 and switch 8 to zeros, we're not using them. But for the test bench, we are looking at the rest of the switches. So we have from switch 0 to switch 7, which means 8 switches. So we are generating 2 to the power 8 different combinations. That's 256. And for the I, we'll substitute that in the switches, and we'll see what the output will look like in ModelSim. We need to compile, and we also need to simulate in ModelSim. So let's go to the DE1 SOC and make it our top level entity, and then compile. Start compilation. Yes. Okay. After compilation is done without any errors, we're ready to open the ModelSim. RTL simulation. Okay. So here's ModelSim. We go expand work and double click on the DE1 SOC test bench. Okay. And then we are not interested in everything here, although you can drag all of them and see how they perform. Or just pick the switches you're interested in. In our case here, we're interested in switch 0, switch 1, switch 2, and for the LEDR, we are interested in LEDR 0 and LEDR 1. Okay. And then let's run the simulation. So simulate, run all. Okay. So here, the result of the simulation. So if we click here, let's look at what is going on. So we have switch 0 is on, switch 1 is on, switch 2 is 0. So this means we have 2 inputs, on, and 1 input is off. So the result should be the sum is 0 and the carry is 1. And then you can try other inputs. So switch 0, switch 1, both are zeros, and switch 2 is 1. So in this case, we have the sum as a 1 and the carry as a 0. And as a reminder of what switch 0, 1, 2 corresponds to in the full adder module, if we go to the DUT and double click it, we will have it open here, the SV file. And in this, at this line, the switch 2 corresponds to the A, switch 1 corresponds to B, switch 0 corresponds to C input, the LEDR 0 for the sum, and LEDR 1 for the C out. If you want to go back to the waveforms, you click this tab to verify. Okay. When we are done, you can close the simulation. And go back to the quarters in case you need to do any further changes to your code. Remember, any change needs new compilation, and the module that you are testing should be your top level module.